Dear viewers, welcome to another video in the series of Minitab tutorials. In one of our previous videos, I have explained how to perform Anderson-Darling test to check whether the underlying data is normally distributed or not using Minitab statistical application. In today's video, we will see how to check whether the underlying data follows normal distribution or not, but this time we are not going to use Anderson-Darling test. Instead, we are going to use Kolmogorov and Smirnov test. So what exactly is the difference between these two and how this Kolmogorov and Smirnov test can be performed using Minitab is what I'm going to explain in this video. I'm also planning to post another video on how the same Kolmogorov and Smirnov test can be performed in Microsoft Excel, step-by-step calculations and the corresponding p-value, so that people who don't have access to Minitab can still do this Kolmogorov and Smirnov test using Microsoft Excel. I'm planning to upload this Excel version of Kolmogorov and Smirnov test as a members only video. I make an appeal to the audience to kindly take up a membership with our channel for a very nominal fee so that you can understand the detailed in-depth statistical analysis. Now let's get into the video. As I was explaining in the introduction, today's video is about Kolmogorov and Smirnov test, which is a goodness of fit test, like an Anderson-Darling test. What is a goodness of fit test? It is not designed only to check whether normality, it can also be used to check whether the data follows any specific distribution. But in this case, we are going to use Kolmogorov and Smirnov test to check whether the data follows normal distribution or not. The symbol or the test statistics for this test will be called D. The null hypothesis will be the data comes from a specified distribution. In this case, it's normal distribution. And the alternate hypothesis is the data do not come from a specified distribution, which is the data do not follow normal distribution. And the key statistics or how this Kolmogorov and Smirnov test would work is, it is basically a non-parametric test used to compare whether the sample data follows a theoretical distribution. So if we take a sample and then if we are checking it against normal distribution, then the result could be yes, your sample data follows normal distribution, or no, your sample data does not follow normal distribution. And how the decision is being made? The decision is being made by measuring the maximum distance between the empirical and theoretical cumulative distribution functions, which is nothing but is your sample data following the expected cumulative distribution function of a standard normal curve. If it is not following, then the distance between the theoretical and the actual data cumulative distribution functions will be large. And if it becomes very large, then the data will be declared not normally distributed. If it is not so large, then the data will be declared normally distributed. So you'll understand this in detail when I am taking you through this exercise of doing it in Minitab. You will even find it even more easy to understand when I am walking you through how to do the same Kolmogorov and Smirnov test using Microsoft Excel. And when can we use this? For a sample size which is greater than or equal to 30. This is, or the test will be good if we have a good enough sample size which is at least bare minimum 30 or more than 30. And one difference between this Kolmogorov and Smirnov test against the Anderson-Darling test is, Anderson-Darling test is designed with the test statistics in such a way that it is more sensitive towards the tail of your distribution. However, Kolmogorov and Smirnov test gives equal weightage for every single data point. Any data point too far away from its expected cumulative distribution function, then the data will be declared non-normal. And when do we use it? As I told, if you want to compare a sample against a known distribution, we can use it not only for normality but for any distribution. The advantages of using a Kolmogorov and Smirnov test is, from a calculation point of view, when you do it in Excel, it is relatively easy compared to how it is being done in Anderson-Darling test for that matter. And the limitation is, it is less powerful when it comes to identifying non-normal behaviors in the tail or small samples. So this part of the Excel explains about the formula being used when we do it in Excel. Anyway, for the Minitab part of the video, we may not spend too much time on this, but I will take you through step-by-step explanation of how this formula will work during my Excel based explanation of the same concept. Now we will move to the decision making part of this. The decision is made by looking at the p-value. So when you complete this exercise, Minitab will give you a p-value, and if the p-value is less than 0.05, we will reject the HO. That means we will reject the null hypothesis. Rejecting the null hypothesis is nothing but the data do not come from normal distribution. And if the p-value is greater than or equal to 0.05, then we fail to reject null hypothesis. Fail to reject null hypothesis is nothing but yes, the data come from normal distribution. So this is how this Kolmogorov and Smirnov test works. So I have given you a theory and the logic and how to make the decision. Now let's move to the data. So here I have a data where I will be focusing on 30 samples. I have used the same data for my Anderson-Darling test as well. So these are 30 sample data points from 30 baby boys with the age of 5-year-old. And this data I have copy pasted and already kept it in my Minitab. Now I can click on stats, I can click on basic stats, and I can go to descriptive statistics. And here I can select weight of 5-year-old baby boys, and I can choose my y values. I can choose reference line at my y value and also at my data values. However, I'm not going to do that. And I have a choice to select which normality test that I want to go for, and I want to go for Kolmogorov and Smirnov test. So now when I click OK, I get this particular session window as a output or graph as a output. So let me copy this graph and take this to my Excel file and paste it here. So what is the decision making parameter? The decision making parameter in this case will be the p-value, and we already saw the p-value. If you see, the decision making parameter is p-value greater than or equal to 0.05. We are going to go with null hypothesis. So here the p-value is greater than 0.150, so definitely greater than 0.05, and our null hypothesis is yes, this data come from normal distribution. However, we will generate one more graph which will make this analysis even more interesting. Generally, when we do a Anderson-Darling test, we will only look at this probability plot, or in other words called PP plot, probability plot drafted against the y value. So this is y value and this is the probability of the data, and we will see whether the dots are falling on this horizontal or this diagonal red line. However, for this Kolmogorov and Smirnov test, it will be interesting if we draw the another graph, and that graph is, so you can click on graph and you can click on empirical cumulative distribution function. Now what is this empirical cumulative distribution function? I can select this and I can say single variable, and here I can say weight of 5-year-old boy. Now I can go to distributions, and in this distribution I can select a variety of empirical distributions, but here my choice is normal distribution because I want to check whether the data is normally distributed. And if I have a known value of mean and standard deviation against which this has to be done, I can even enter those values, but this time I don't want to do this. I want Minitab to take the mean and standard deviation from the sample data that we have given. So I'm going to leave this mean and standard deviation columns blank, and now I hit OK, and then I again hit OK. So when I hit OK and OK, I will be able to get this value. So let me copy this value, copy this graph, take this to Minitab and paste it here. And friends, if you see this Ks value, which is the Kolmogorov and Smirnov value, 0.065. So the 0.065 is nothing but the maximum deviation between the theoretical cumulative distribution function for a normally distributed data and the empirical distribution. Empirical distribution function is nothing but the one which comes out from the data. So the data may not exactly follow normal distribution. So for a given average and standard deviation, your distribution is supposed to follow. So what you see here, it is supposed to follow this red color curved line, but against this red color curved line, our data is deviated little bit. So the deviations are getting mapped, and whichever place where the deviation is maximum, that will be then declared as your Ks value, because we saw the formula says maximum deviation between the empirical cumulative distribution function and the theoretical cumulative distribution function. So what is the maximum distance? Let's get back to Minitab and let me explain you using Minitab only. So in Minitab, if I start keeping my mouse pointers, if I keep my mouse pointer here, this is the value, theoretical value, and this theoretical value is so far deviated, right? And similarly this theoretical value is so far deviated. So we are measuring the deviations, right? The vertical deviations of the theoretical and the empirical distribution. The theoretical distribution is represented in the red line and the empirical distribution is represented in the blue line. And if I keep placing my mouse pointers, so you will find the values here. So in this, whichever is the maximum distance, so here it's very difficult for us to identify which is the maximum distance, but when we do this calculation in Excel, you will know which is the maximum difference or maximum distance. So just to make you understand, anyway I'm going to make a separate video on how to do this calculation in Excel. However, if you see the maximum distance, here I have done this calculations. I will explain you step by step how it works in a different video, but here if you see, the maximum deviation is 0.6469 and the 0.06469 is nothing but 0.065, and that is coming against the data of 17.55. So now if you come here and here you have 17, so if you keep your mouse pointer somewhere on the 17.55, so 17.55 will be somewhere here. So the 17.55 is when there is a maximum distance between the empirical distribution and the theoretical distribution. Against the 17.55, whatever is the deviation, that deviation will be reported in your Minitab as the Kolmogorov-Smirnov value. So anywhere if the deviation is too high and if you find a data somewhere here very far away, then that will be declared as your cumulative distribution delta. So just to make you understand, let me put a value which is very different from the rest of the values. For example, let me put 13. Now if I press Ctrl E and take this data one more time and click OK, you will find that one data point is very far away. And for example, if I try to use this stats, basic stats, normality test, and with that one data point being very far away, if you see, this data point would have attracted a very high KS value, so 0.095, and because of this your p value will go little bit different. So this is how we will understand the Kolmogorov-Smirnov test. So this distance of the data point from, so this distance is how far is this data point away from its expected probability curve, and what you see here is again how far. So here is the theoretical graph or theoretical cumulative distribution function. So if you keep your mouse pointer on this, here is the theoretical cumulative distribution function and here is the corresponding value, and this value is very far away from the cumulative distribution function, and that will be declared as your KS value. Friends, I hope this video was helpful. As I was explaining in the beginning of this video, I have made a separate video on how to do this Kolmogorov-Smirnov test using Microsoft Excel and how to arrive at the p-value and make a decision. So I am planning to upload that video as a members only video. So I make an appeal to the viewers of this video to kindly take up a membership with our channel for a very nominal fee, so that you will be able to understand in-depth statistical analysis, and that video involves step-by-step calculation and how you will use the Kolmogorov-Smirnov table to make a hypothesis test result, and also there is step-by-step method of how you can arrive at the p-value. So these are the things that I am planning to cover in that video. So people who have requirement to understand this at a Excel calculation level, right, those who don't have access to statistical applications like Minitab and would like to know how it is being done in Excel, I would kindly request you to look at the other video that I have made. So this video is how we can get the results for a Kolmogorov-Smirnov test through Minitab statistical application. I hope this video was useful. For more videos on statistical analysis and Minitab tools and techniques, I would request you to kindly subscribe and follow our channel. Thank you for your time. See you in another video.